Welcome to today's roundtable webinar brought to you by Tamr, Appen, and Molecula. I'm Stephen Faig, Director at Database Trends and Applications and Unisphere Research. I will be your host for today's broadcast. Our presentation today is titled Overcoming Data Management Challenges in Machine Learning. Before we begin, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the submit button. We'll try to get to as many questions as possible, but if your question has not been selected during the show, you will receive an email response. Plus, all viewers today will be entered for a chance to win a $100 Amazon gift card just for participating. Now, to introduce our speakers for today, we have Luis Baldwin, Solution Director at Tamr, Sujatha Sagiraju, Senior Vice President of Product at Appen, and Dennis Cody, Technical Product Manager at Molecula. Now I'm going to pass the event over to Louise.
Fantastic. Thanks, Stephen. So it's great to have the chance to deep dive on how we apply machine learning to data mastering at Tamr. So maybe to start us off, who is Tamr? So Tamr is a next generation data mastering platform that delivers clean, accurate data by breaking down data silos using human-guided machine learning. So today is going to be a bit of a whirlwind overview. So I thought I'd start out with a little bit of Tamr's history and background. So Tamr was founded at MIT off the back of work by Dr. Michael Stonebreaker and several of our founding engineers, summarized in this paper mentioned on screen that addresses the true problem we're solving, so data curation at scale. Since that paper, we haven't just dropped the E from Tamr. We've been innovating year in, year out in areas such as collaborative ML at scale, big data duplication, as really new standards in scale and efficiency have advanced over time. So today we're mainly going to talk about machine learning for data mastering from the perspective of Tamr, but hopefully there'll be some value from the key principles, even if you're building your own solution, and we'll have some follow-up materials where you can dig in. So when we think about the problems that we're solving, we're going to look at it first from the perspective of Toyota Motor Europe, one of our longest standing customers. So the company had launched Consumer One, a European-wide initiative to boost business by putting the customer even closer to the center of Toyota's activities. So the idea was really that operating with a more customer-centric view would not only just increase customer satisfaction, but also fuel expansion for them. So the goal was that customers, everything from individual people to organizations thinking through fleet customers, would have that consistent experience, and that to be able to advance predictive analytics for customers and really raise the bar on data-driven decision-making for their sales and marketing teams. So the ask itself seems pretty straightforward, but the question is, how do you get there? Things get interesting when you start to think through the problem at scale. So in Toyota Motor Europe's case, hundreds of data sources on its customers. As you'd expect, CRM installations were highly customized by region, many divergent schemas, many different taxonomies that go with it. About 30 countries, and the need to be able to assess the data on that national, regional, and dealership level within it. And as you'd hope for a functional business, everything's naturally live. So new customers, new categories, new CRMs were being added week to week. And when we think about what that means for what's required, well, breaking it down to just the basic steps, finding all the relevant data. So from ERPs to data lakes, also data living in Excel, standardizing representations. The most glaring ones, sometimes the representations across countries like currencies, cleaning, postal codes as numbers, etc., mapping schema so that there's an integrated schema across sources, entity mastering, which is key to the solution as a whole, really creating that holistic view by being able to recognize where the same customer was represented across different sources. Categorization, considering aspects like fleet versus individual customer. Survivorship then, if a fleet customer is acquired by another organization, thinking through who survives, how do I represent it? And then ultimately, from the clustered records, to be able to identify the best data, the golden record. So if I have 10 addresses clustered, for example, what is the best one? And it's not just about doing it. naturally about doing it at scale, doing it in production. And so those challenges really coming through. So when we think of data at scale, automatically think record size, but also thinking through aspects like number of columns and sources. What if I have 1,000 columns within a data source? How do I deal with it? In Toyota's case, dealing with hundreds of data sources coming and going. The need to provide high data with high availability, so predictable latency if doing a lookup, the flexibility to do a rollback if something goes wrong, and the need to be able to deploy model updates on a predictable schedule, be it daily, be it weekly, etc. But the business really needing to know and understand how it will happen. And the need to accommodate constant change. So, even aspects like GDPR and cohorts who might want an information takedown, really important aspects when it comes to addressing customer data. And finally, the data will really only be used and trusted if it's vetted by subject matter experts. So those who know the context of the data. Really, this is about addressing kind of the classic business response of, I'll only trust your numbers if I know it comes from a certain source because I know the data best. And of course, this wasn't their first rodeo when we think about Toyota. And, often it isn't. Data unification is a critical problem, and often there's a lot of thought and effort gone into previous solutions. So in Toyota's case, they've been trying to build the customer portal for a while. They had been working with some external agencies, also handcraft scripts and some legacy MDM suites. What they found is that they could do it, but with relatively static data sources. But where it tended to struggle was at scale. So when you look at 200 plus data sources that were constantly growing in complexity, things started to break down. So in short summary, with Tamr, they integrated 261 sources with no disruption to local systems, as you'd expect. They were onboarding sources in about a week. And maybe as a more tangible example within that, the TME France CRM migration, that's taking place in about 6 weeks, which, is often about 1/10 of the time less than how it can typically take for the CRM migrations. So I want to get into some of the meat of kind of the core principles that Tamr applies when thinking through the problem. And there's really kind of 3 themes that our machine learning approach is built upon. The first, robust data unification workflow. The second, efficient and high impact user input. And the third, then application at scale. So if we get into the first and think through robust data unification workflow and what it means to us. So our focus is really on producing the best data. So our machine learning approach is pre-configured to support unification. We're not thinking about an open world machine learning problem. We know that what we're trying to do is map schemas across sources to match and cluster records, to be able to categorize at scale, and to be able to create golden records and unique IDs to capture the best available data. So we select models, algorithms, hyperparameters, and data features that support these specific use cases. We've pre-selected the loss functions, managed training data selection within that, and have this sort of pre-built active learning workflow that really powers the subject matter expert-oriented workbenches that are central to our solution. And we'll go in a little bit more detail on that in a bit. Within this, we have automated training data management. So this is taking care of aspects like closed-out samples, k-fold learning, active learning, cross-validation, all of this built into the platform so that you don't need to spend your time and machine learning talent on it. It's built to really rapidly converge on a high-quality model, and our approach and Tamr's approach at whole centered on data ops and the belief on this sort of agile approach to data management. So the next big theme, efficient, high impact user input. So typically when we think through traditional tools in the space, let's say a traditional ETL tool, often the technical persona is in control of building and deploying the solution. In Tamr's case, we build workbenches that are around subject matter experts to bring those that know the data into the flow so that they can see what's going on and tune the system. They can validate the results so that the people using the data and the organization as a whole can trust the data that's being produced. We're focused on that ability to give rapid feedback in minutes to make sure that they're engaged throughout the feedback cycle. And so taking sort of one simple example of how that's actually reflected within product, here we're looking at a pair comparison. So getting the subject matter experts, those who know the data, to answer just simple yes or no training questions. As basic as, are these two records a match? Meaning, do they represent the same entity? Yes or no? And naturally, if a human can identify whether two records are a match, Tamr can learn to replicate it. Even within that, though, there's obviously pair comparison at scale is a large challenge. So we're always focused on thinking through how can you get user feedback and input on the model as efficiently as possible. So Tamr identifies high impact training questions that will have the most influence. So pairs in the target schema and source data sets that are highly representative of other potential pairs, but where Tamr has low confidence. So users can focus on answering these questions so that they can scale efficiently. So in this example that we have on screen, you can see that Tamr selected 50 of just over almost 12,500 potential pairs for review as high impact. And so the model input is done iteratively. So as new sources are added, the user can respond to high impact questions and the model performance can be improved quickly. The same workflow that we're showing, the same principles are also applied to cluster review. So again, it's really iterative and integrated throughout the workflow. And sort of the final category of thinking through scale. So none of what I just chatted through really matters if the algorithms can't handle data at scale. And so starting out with that need for scale. So if we break it down at a basic level, so entity resolution is really an n squared problem, with n being the number of records. And so if we think this through in a classic, customer mastering case, you might have 10 million records. In scale, that's 100 trillion comparisons. Clustering is even more difficult than that. It's worse than n squared. So here, if n is the number of edges in a connected component, if I take all of the customers that might be related, if I look at the relationships between them around the edges, it escalates. So we can see real-world cases with over 50 million edges to consider. And then categorization being n times m, so n number of records, m the number of nodes in the taxonomy. And so unification really needs to be smart and scale smoothly on commodity infrastructure in order to take advantage really of elastic and ephemeral compute in order to be able to manage that cost of the job. And so naturally, we have to think through building algorithms that scale. So we have a bunch of patents on the technology, a few maybe to highlight. So the first is adaptive blocking, really, where Tamr learns a high recall, low precision model to partition the n squared space. So, our approach accommodates for kind of the natural, messy, and changing data that you'd imagine. The second is optimized clustering. So it's reducing that complexity from something really worse than an n squared problem to something more comparable to n log n. And so, figuring out an efficient partitioning of the problem is essential. So within a connected component in this case, so that it scales cleanly on distributed compute, so that you don't have this long pole problem. So you can imagine, where you have one 200,000 record cluster that takes a week after the others have been computed. And finally, large-scale categorization. So we use clustering to reduce effective record count. So using adaptive blocking and hierarchies to prune the taxonomy on the matching problem. And so we started out with TME and kind of the customer perspective, and so it only feels right that they also get the last word. But I think these two quotes that we're highlighting very much summarize the value prop and also really just Tamr's approach to the problem as a whole. So the first from Matt Stevens at Toyota emphasizes just a focus on a bottoms-up approach that is about prioritizing scale, flexibility, and collaboration. The second from Yves is the power of the platform. And really, at its heart, Tamr is an entity-agnostic approach. So we always want to apply Tamr to solve very tangible, very well-defined business problems, like those of Toyota Motors Europe's marketing and sales team. But as a platform, the potential to innovate on use cases and expand beyond just a single use case is huge. So as mentioned, for those that want to do a deeper dive and on some of the material we covered, we have some follow-up materials that we can provide, and we'll go in a little bit more in-depth on some of the features and functionality and really thought behind Tamr as a whole. And so with that, I'll hand it back over to Stephen. But just to mention, I know we're taking questions at the end, but if you do have any questions as follow-ups from today's session, please feel free to drop me or anyone at the team a note. And if you pop on to the website and you'd like to see more on the technology, you can see it at Demo Day, See Tamr in Action, and you'll get a more thorough overview of the tech. Over to you, Stephen.
Thank you very much, Louise. That was a really interesting case study. So at this time, I'd like to introduce our next speaker. We have Sujatha Sagaraju, SVP of Product at Appen.
Thank you, Stephen. Hello, everyone. I work at Appen, where I'm privileged to lead a very talented group of product managers, design, and marketing teams. Prior to Appen, I was at Microsoft for 20 years, working on large-scale online services in Bing and ML platforms in Azure AI. Today, I'm very excited to share with you about an emerging discipline called Data for AI Lifecycle. As a part of my job, I get to interact with a lot of customers on a daily basis to learn about how they're thinking about AI in their businesses. And I have witnessed firsthand a transformation that has happened in the industry. Just 5 years ago, majority of the customers were trying to figure out how AI can solve their business problems. Now these customers have identified business-critical applications that can be powered by AI. They have staffed data scientists and other teams needed to build the AI solutions to drive the company bottom line. At Appen, we see companies' AI budget increasing by more than 50% year over year. And if you imagine the day of a life of a data scientist at these companies, the mental picture you will get is a data scientist thinking about algorithms, fine-tuning the models, and getting the insights from the models that they trained. But what happens in reality is that the data scientists spend over 80% of their time working on the data and getting it into the right shape so that it can be used for model training. Many companies are coming to the realization that the real challenge in building an AI solution lies around the data. Let me walk you through the life cycle of an AI project. When we think about how customers build AI solutions, there are 4 stages. In the first stage, the customers source the data. The second one, they prepare the data, which includes annotations. And the third stage, they train and deploy the model. And in the fourth stage, after the model is deployed, They evaluate the model performance with human-in-the-loop testing. Data for AI lifecycle focuses on developing the tools and best practices to enable businesses to reduce complexity and manage data throughout the AI development process with a data-centric lens. Now I'll go over the challenges and opportunities in each of the stages of AI lifecycle. The first big challenge for a company building an AI solution is the need to acquire or collect the data needed to train models. This is no easy task, especially if you want to do it in a responsible, ethical, and scalable way and high quality requirements. At Appen, we found that an overwhelming majority of organizations have partnered with external training data providers to launch AI projects at scale. And this is a reflection of the fact that data acquisition is a big challenge that AI practitioners face today. Pre-labeled datasets can accelerate AI projects or at the minimum kick off a pilot while you're waiting for data collection. For complex AI projects, data sourcing can be outsourced to external vendors. My recommendation is that you should take the time to find the right vendor who can meet the quality requirements and ensure that the datasets are ethically sourced. Lastly, there is an emerging area of synthetic data that can be used to leverage for hard-to-find data at scale to enhance model training. Simply acquiring training data isn't enough. Whether working internally or externally or with an external training data provider, the AI team must ensure a continuous flow of updated data critical for production models that deal with changing inputs. There, the work is never done, or the models start to drift. Also, project teams want more data faster. So they can't rely on one-time projects and ad hoc collection or annotation projects. With the goal to expand current AI projects and implement new ones, businesses must find new ways to streamline project creation from pilot to production and create consistent and accurate processes that can scale. This can be achieved only through automation, especially around data sourcing and preparation. Data preparation is critical for AI project success, and this is the step where teams typically work with a globally diverse group of people to annotate, rate, judge, and label data to create high-quality data inputs for model training. You have to absolutely make sure that there is minimal bias in your label data. Otherwise, if you have bias in your data, it will become the age-old problem of garbage in, garbage out. The bias in the input data will lead to incorrect predictions of your models. Businesses must confront the challenge of making their machine learning models inclusive and eliminate bias from their data. Biased data can kill an AI project. First, biased data can lead to unfair practices. For example, making decisions on loan applications based on race or gender instead of actual analysis of credit or risk. This can result in the failure of a project, a negative impact on a protected group, or public backlash that can damage the brand. Second, if the results are not immediately damaging or publicly embarrassing, biased data can mean that model prediction results are simply suboptimal, so the businesses never achieve the intended ROI from the AI application. In the data preparation stage, you might also tap into the knowledge graph and ontology management tools to turn data into intelligence. The model training and deployment stage is where you will have several choices to choose from in terms of compute provider, ML platforms you'll be using, and the frameworks you'll use to build the models. Whether you work with your in-house team of engineers, data scientists, or choose to work with top consulting or technology provider, it's important to make sure that your data providers in step 1 and 2 connect well with your model infrastructure. This is important for the initial development iteration, but also for the next stage as well. With the new discipline of data for AI lifecycle, we see two things developing for 2022. First, no single company can provide solutions across the entire data for AI lifecycle. We expect to see a variety of new partnerships to make this discipline a reality. Second, AI practitioners don't need a tech stack that has multiple siloed applications that increase complexity and require separate complex administration. That's why we're expecting winning solutions to combine partners with a streamlined interface that simplifies and accelerates the data for AI lifecycle process. The fourth stage of model evaluation is where AI projects turn into programs and teams watch for model drift for continuous improvement opportunities. There is huge value from sourcing real-world model performance validation and tuning across a range of use cases and demographics, especially for organizations that have a global audience. And this is where it's a good practice to compare your model performance to competitors and peers to ensure best-in-class results. If you're going to choose a vendor for data for AI lifecycle needs, there are a few criteria that you should look at when you evaluate different vendors. The first criteria is the most critical one. Can you trust the vendor with your data? Do they have security, compliance, and data privacy top of their mind? Second is the quality of the results. Will the vendor provide high-quality results with all the guardrails built in for minimizing bias? The third one is whether the vendor platform and services are easy to use. Another key criteria to consider is the breadth of coverage and expertise of the vendor, whether they'll be able to scale effectively as your scenarios, data types, and data sizes scale. And the final criteria is the speed, whether you can get high-quality data quickly in order to kickstart your pilots and move the pilots into production. Thank you for your time. Finally, just a little bit about Appen. Appen is a leader in the data for AI lifecycle with over 25 years of expertise and is trusted by global brand name companies to power the mission-critical AI applications. Appen covers a wide array of data types, including audio, video, text, image, multimodal, speech, location. And if you have any questions, please do not hesitate to email us. Over to you, Stephen.
Thank you very much, Sujatha. That was great. Okay, so I'd like to introduce our final speaker today. Last but certainly not least, we have Dennis Cody, Technical Product Manager at Molecula.
Thanks, Stephen. Hi, everybody. So I'm here today to talk about the challenges and trade-offs we face every time we try to design real-time data infrastructure for machine learning. But first, let me just introduce Molecula and myself. So Molecula is a technology company focused on enabling organizations to unlock the power of real-time analytics and AI. How we do this is actually going to be the subject of today's presentation. And a little about me. So I'm a product manager here at Molecula. I've spent the past decade architecting, deploying, and using big data infrastructure to answer questions and solve challenges in finance, healthcare, and national security. Many of the things I'm going to talk about today are challenges and conversations I've personally seen time and again. In the last 15 years, we've seen an explosive growth in big data providers and big data usage. We've seen the birth of trillion-dollar companies and a democratization of analytics for everyone. Great news. Anyone with a credit card can now store and query big data. But as we continue to expand automation, machine learning, and AI, we're going to need that infrastructure that gets us answers faster. And a lack of real-time capability hinders not just our current opportunities, but limits future possibilities. So I just want to share with you today some examples where speed of analytics matters. For instance, H&M is a fast fashion business who built their brand on getting fashion ideas from the catwalk to production to shelves as fast as possible. Their business model is literally built around speed. For folks like me who are, let's say, fashion challenged, another example is Pfizer and Moderna, who have both stated that leveraging new data analytics and machine learning was one of the reasons for their historic speed to approval for the COVID-19 vaccine. In particular, Pfizer noted that the time to prepare trial data for analysis was reduced from a typical time of more than a month to just 22 hours. Now, for developers of application in this upcoming age of intelligence, we're going to need to consider 4 requirements in order to meet the demands of real-time analytics. So let me quickly just summarize these 4 requirements and give you some thought-provoking questions to ask yourself. So models are going to need low latency to act on questions in real time. Are your queries fast enough? To be accurate, models need fresh data to stay relevant. So how quickly can you act on data after it's been created? High throughput is necessary to keep up with the ever-increasing amount of data being generated all the time. So can you store and make available data as fast as it's created? And many models and applications have to run concurrently at the same time. Can you support them all simultaneously? Most tools on the market excel at 1 or 2 of these, but they can't meet all 4, which is why we believe implementing machine learning at scale is proving to be so difficult. Now, there's no such thing as a free lunch. I would know. I've been tricked into more than my fair share of sales pitches because of them. So what are some of the common and traditional trade-offs we face when building out data infrastructure? Well, some of them might be freshness or latency. Do you denormalize queries ahead of time or perform expensive joins on the fly? Latency or throughput. Do you choose a read or write-oriented database? Latency or concurrency. Do you have a no rules free-for-all where first query wins? Or do you preemptively reserve resources based on needs? Unfortunately, current technologies force you to negotiate and prioritize what means most to your business. But production machine learning applications are actually going to require a minimum threshold for all 4 of these pillars. So let's dive into each of these workarounds and see how they're impacting your business. So typically, we see customers with multiple data sources. And they'll populate a normalized data model. This model data is broken up into separate tables like users, views, and items. Maybe it's e-commerce. To analyze data across these separate tables, complex joins must be done, which ultimately increases latency and makes queries slow. Now, one strategy or workaround for reducing latency is to denormalize the data or pre-aggregate it by performing these joins ahead of time. This will reduce latency, but that pre-aggregation can take minutes, hours, or even days, meaning that the data you're using for analytics and to make decisions about your business is probably out of date by the time you can actually use it. Additionally, these processes are actually quite inflexible, and when, not if, you need to add or change features, it can take days to weeks to modify a production environment. Another trade-off you might have experienced is between latency and concurrency. If you're powering machine learning applications, that likely means there are hundreds, thousands, or potentially millions of users and applications at a given moment. Rarely will just a single lonely query be running. Now, every database has a breaking point. And after a certain number of concurrent queries, the latency skyrockets. For instance, as you can see in the slide, BigQuery caps concurrency at 100 queries per project. This is because finite compute resources have to be divided and shared. So queries either have to compete or wait for these resources. Now, some workarounds are to partition resources based on use case or business structure or prioritization of queries. But this is inflexible and ultimately reduces the efficiency you can get from your hardware. So what about latency versus throughput? It looks familiar because it's actually the same graph with the same problems. Compute resources need to be shared by both ingest processes storing data and the query engine serving results. Where you might see this trade-off is when you start seeing the phrases write-oriented or read-oriented databases, because their architecture is designed around either a write-often, read-few access pattern for something like a log store, or a write-few, read-often access pattern for something like a cache. Ultimately, the CPU can only do so many operations at once, and they have to be spent wisely on both ingest and queries. Now, there is a trade-off that suspiciously has been missing up until this point: cost. Many of these trade-offs can be resolved with more hardware, but there's a sneaky fact about cost with big data, and that it actually grows exponentially with complexity. More hardware requires more staffing requires more management, and now your small and nimble organization is much larger and much less nimble and efficient. The amount of capital and resources needed to pay off these trade-offs quickly spirals out of control for most organizations. So why are you forced to negotiate trade-offs with your data infrastructure? At the heart of it, it comes down to resource allocation. Traditional OLAP databases run on columnar data format, which, while impressive, can be improved on in many cases. For most true analytical workloads, there's actually a far more efficient format that allows you to enjoy the benefits of the 4 pillars on significantly less hardware. So let's talk a little bit about data formats and compare our feature-oriented format on the right to row-oriented and column-oriented formats on the left and middle. Row-oriented formats are great for transactional data, where queries are done on a record-by-record basis, but they do poorly when looking for patterns or statistics about the data set. Column-oriented formats were a breakthrough. They're tailor-made for analytical queries since they break out the data by column and reduce how much data that actually needs to be read from disk. But there's still much to be desired in terms of latency when dealing with large data sets. Now, this is a problem because machine learning models typically require significant amounts of data to be useful. To have a real-time machine learning model, this will simply not suffice. At Molecula, we have an ultra-low latency database, FeatureBase, that further revolutionizes the data format in a feature-oriented way. Let's dig into that a bit deeper. Rather than storing data in a human-readable format, we leverage a compressed machine-native format that stores individual values and their relationship to records as binary ones and zeros. We've made the index a first-class citizen. Now, a unique benefit to our format is that it's optimized for modern CPU architectures. Now, what does that mean? That means CPUs can perform operations on this format in a single instruction in a cache-friendly manner. This is what allows for ultra-low latency queries and super high CPU efficiency. Ultimately, we enable customers to reduce their hardware footprint, typically by 90%, and we can reduce query latencies to milliseconds. It's purpose-built for large-scale, real-time analytics and is much more performant and efficient than columnar data formats. There's actually another reason we refer to our format as machine native. The way we communicate efficiently with CPUs is the same way many machine learning algorithms want to see an input into their models. This is because one-hot encoding of features is how we store and communicate. It's no longer a step of feature engineering, it's actually built in for free. Here you can see how a query might execute in FeatureBase. Now, a feature-oriented format is the key to achieving the 4 requirements of the intelligent analytical stack with massive scale data sets and without the typical trade-offs you're making today. And it's the format that underlies our product, FeatureBase. So FeatureBase is an ultra-low latency database that sits on top of conventional data models, such as relational or star schemas, data lakes, and streaming tools like Kafka. We can maintain up to the millisecond data updates with practically no data preparation. It can enable you to power workloads using the freshest data by eliminating the need to perform data aggregation steps with 10 times compression on traditional columnar databases and greatly reduces the compute necessary to power workloads. To finish off, I'd like to share with you some success stories we've seen so far with customers. For one of our customers, they're a leading technology firm who is currently using us to power all of their email marketing campaigns. They saw their data aggregation time reduce from 8 hours to 8 seconds, and query latency drop from minutes to milliseconds due to our unconventional approach. Another one of our customers is currently using us for a network security use case. Now, while we routinely see a 90% reduction in hardware footprint, this particular customer reduced their data footprint from 35 terabytes to 350 gigabytes, a 99% improvement. This impressive result allowed them to also dramatically reduce compute resources as well. With that, thank you for listening. Back to you, Stephen.
Thank you very much, Dennis. At this point in time, we're going to dive into questions from our viewers today. The first question is for Luis. Luis, how long does it typically take to train the model?
Yeah, that's a great question and always a tricky one to answer in a machine learning context. So it does vary with the level of training effort from project to project as the scale and nature of the data naturally changes. But it's typically about 1 day of input. So if we think about, a scale of maybe 1 to 5 million records, typically takes about 500 yes/no match pairs really to have a solid model in place. Typically about a day.
Understood. Thanks, Luis. Sujatha, our next question is for you. What step in the AI life cycle do you believe is most crucial for success?
The way to think about it is not which step is crucial. It's about where you spend most of the time. In building an AI solution, majority of the time, in fact, more than 80% of the time is spent on the stages that relate to data, specifically data sourcing, data preparation, and model evaluations.
Understood. Okay, Dennis, our next question is for you. Can you explain a bit more about why this feature-oriented format is more performant than columnar?
Because I said it is. No, I'm just joking. So actually, being feature-oriented means that we can deduplicate data as unique features. So let's think the color of shirts people are wearing. we can store the label read once and then use zeros and ones to label each record as being read or not read. So right there, there's inherently a reduction in how much data we have to store. To go a little deeper, the feature-oriented format is all about binary and being friendly with CPUs. And we can take advantage of CPU operations, specifically, if we want to go deep, in the arithmetic logic unit of CPUs, which actually does the compute, to literally run a billion times a second. And we can take advantage of on-chip caches to check if records have the correct features I'm asking for in a query. So it's just ultimately we're playing the game that CPUs want to play.
Understood. Thanks for clarifying, Dennis. Luis, back to you. When you were discussing your case study with Toyota, we had a question come in. Can the application manage both structured and unstructured data?
Yeah. So Tamr primarily operates on structured and semi-structured data. So within unstructured, if it's JSON, XML, we could probably work with it. Images, video files, not so much. So record level data can be free text or unstructured, but it does need to be in tabular form. And if the data isn't in tabular form, it can often be converted and used within Tamr, but that conversion isn't a native capability of our product.
Understood. Thanks, Luis. And Sujatha, would that be the case with your product at Appen as well?
Yeah, we deal significantly with the unstructured data, and we enable customers in the 3 of the 4 stages of the AI lifecycle. For example, on the data collection, again, an unstructured example is where we did the data collection for Amazon to build Alexa models. And we also provide pre-labeled data sets for several customers that you use to enter new markets. And we also have unstructured synthetic data. And in the data preparation phase, we do labeling for lots of customers like Boeing, Home Depot, and also federal agencies like Raytheon. In the 4th stage of model evaluation, we do the Bing search relevance model evaluation.
Understood. And Dennis, is that the case with, where does FeatureBase stand with regard to unstructured versus structured data?
Yeah, so during ingest, as we start ingesting data into FeatureBase, it looks like a traditional structured database. However, we offer a lot of tools to help map unstructured data during the ingest process, because that's where we are also doing the feature extraction work as well. So it's going to eventually look like a structured database, but the way we ingest is relatively flexible and friendly to both types of data.
Got it. Okay, Louise, question for you. How do you provide transparency on the model?
Yeah, which is always key, right? Making sure that you're able to sort of track changes, that it doesn't become a black box. So it is essentially critical to, when we think about it, primarily within a cluster review, for example. So we make sure that within product, you can review changes and you can update published, clustered, and track throughout. So one important feature within that is like cluster lineage over time, so that you can see how the data and the clusters are changing and really track model performance. Governance is a really important sort of mastering component in general. So it's something that is naturally built within the Tamr offering.
Understood. Thanks, Louise. Sujatha, our next question is for you. Where does data management fall in the AI lifecycle?
The data management is, again, in every single stage. It's not just about the data in that particular stage of the AI lifecycle, but how do you transition from one stage to the next and make sure you understand which version of the data you're using in which stage and how is the whole transition happening. So it's about the loop and the whole life cycle versus a single stage.
Understood. Dennis, our next question is for you. No solution is perfect, so what are your trade-offs with FeatureBase?
You know, I'm going to pretend and lie and say there are no trade-offs. No, I'm just kidding. So the trade-off that we actually make is that being machine native, we're not in a ready-to-consume format for people. We work with features instead of labels, whereas people like labels. So if we need to return a labeled record for human consumption, then that's actually a relatively expensive operation for us to do. So you can think like select star queries. Thankfully, models don't really care about labels. And so for most feature-leaning use cases, it's really a trade without loss.
Got it. Thanks, Dennis. I have a question I'd love all three of you to weigh in on. With the continual growth of machine learning applications and systems, does that make maintaining compliance and security easier or harder? And why don't we start with you, Louise?
Ooh, easier or harder? I think it's the potential for it to be, this is almost like not quite answering the question, but I think there's a potential for it to be harder if you haven't robustly thought it through, right? Because I think there's more opportunity for it to go wrong from a compliance standpoint. Compliance hates black box situations. But, you know, in Tamr's context, compliance also hates unmanageable rules, right, that become sort of completely untransparent too at the same time. So in our case, I will say that, you know, we work on compliance-sensitive cases. We work with a lot of financial services customers like Scotiabank and Santander, and it really is a sort of a key component. I think in our case, we view it as an opportunity within machine learning to provide more transparency, but I think it can go both ways.
Understood. I think that's a fair answer. Sujatha, would love your input on that.
I would say the trust aspect, which specifically is security, compliance, and privacy, is the hardest problem that Appen solves, so that it's easy for the customers to build compliant, secure AI solutions which have all the data privacy requirements met.
Understood. And sorry.
I was just going to say, it's all about how you do it and who are the partners you're working with. If they have all the trust aspects satisfied, then your job building the AI solution will be a lot easier.
That makes sense. Dennis, your viewpoints on this topic.
Yeah, so this takes me back. I've done a lot of work in high compliance areas. It's hard. Anytime you add compliance or security requirements, it just always will make it a little bit harder, just because there's more checkboxes that have to be double-checked and making sure the rules are followed. In terms of AI ML, you know, areas like in Europe with GDPR, you know, it does make it challenging. You know, compliance does not like black boxes. It does like repeatable results. And, you know, that, much like with people, you know, can be challenging. So, you know, what we do to sort of help in this area is just simply reduce how many machines and how much data, and try to make it more manageable for individuals to catalog and understand and manage with those checkboxes. But oh yeah, it's always a hard problem.
Okay, so we're just about at the top of the hour. Before we break, I'd love to provide each of you with an opportunity to just tell our attendees, if there's one thing you would really like them to keep in mind as we move forward, what would that be? And why don't we start with you, Louise?
Yeah, so I'll probably start with something that's core to Tamr, and it's the most basic, that rules don't scale when it comes to data unification at scale. Often the easy answer starting off, often easy to sort of build your own, but this audience probably being already converted, machine learning at scale is really the only way to tackle the data unification problem.
Understood. And Sujatha, there's one thing you'd like folks here today to walk away keeping in mind.
The one thing I would say is when folks are thinking about building an AI solution, absolutely think about data first, focus your energy and time on that, and make sure you have the right type of data to build responsible AI solutions.
Okay, and Dennis, your final thoughts.
I would say that, I think there's a evolution right now that's taking place where we're no longer making data infrastructure for people and dashboards. I think it's definitely transitioning more to machine to machine and AI and the robots. And I think that there's a lot of opportunity out there to dramatically improve results and performance if we're willing to design our new hardware around this future.
Okay, well, I would like to give a huge thank you for our speakers for coming on board today and sharing their expertise and insights. Once again, Louise Baldwin, Senior Solution Director at Tamr, Sujatha Sagaraju, SVP of Product at Appen, and Dennis Cody, Technical Product Manager at Molecula. If you would like to review this presentation or send it to a colleague, you can use the same exact URL that you used for today's live event. It will be archived, and you will receive an email once the archive is posted. And if you would like a PDF of the deck, you can go to the handouts section on the console once the archive is live. And again, just for participating in today's event, you could win this $100 Amazon gift card. The winner will be announced on January 31st. We will reach out to you via email if you are the lucky viewer. Thank you, everyone, for joining us today, and we hope to see you again soon.